Welcome to the fastest way to learn data structures and algorithms. Today, we're mastering a Bitwise brain teaser, LeetCode 201, Bitwise and of numbers range. This problem looks intimidating if you try to brute force it, but with a clever bit shift trick, it becomes trivial. Let's dive in. The challenge is simple. Given two integers, left and right, we need to return the bitwise and of all numbers in that range, inclusive. For example, if we have 5 and 7, we need to compute 5 and 6 and 7. If the range is huge, a simple loop will time out. We need a way to find the answer without actually iterating. Think of it like two flashlights shining down a row of switches. As the range of numbers increases, the switches at the end, the least significant bits, are constantly flipping between 0 and 1. In a bitwise end, if a bit flips to 0 even once, that entire column becomes 0. Only the steady, unchanging switches at the front, the common prefix, remain lit. Our goal is to find this stable prefix and discard the noisy, flickering tail. The secret insight is this: the bitwise and of a range is simply the common prefix of the binary representations of the start and end values. Why? Because everything to the right of that prefix will eventually flip to 0 at some point in the range. To find this prefix, we shift both left and right to the right until they are equal. We keep track of how many times we shifted, then we shift the equal value back to the left by that same amount to restore the zeros. Let's look at 5 and 7. Binary 5 is 101, and 7 is 111. First, they aren't equal, so we shift both right. 5 becomes 2, and 7 becomes 3. That's one shift. Now we have 2 and 3. Still not equal. We shift again. 2 becomes 1, and 3 becomes 1. That's 2 shifts. Now they are both 1. They match. We take this common prefix, 1, and shift it back to the left by our shift count of 2. 1 shifted left twice gives us 100, which is 4. And that's our answer. In our Python code, we initialize a shifts counter to 0. We use a while loop that runs as long as left is less than right. Inside the loop, we right shift both numbers by 1, and increment our counter. Once left equals right, the loop terminates. Finally, we return left shifted back to the left by our shifts count. It's clean, fast, and incredibly efficient. For time complexity, we shift the bits at most 32 times for a standard integer, making this O of log r, which is effectively constant time. For space complexity, we only use one integer variable for the counter, so it's O of 1, constant space. And that's how you solve the bitwise and of numbers range like a pro. If this common prefix trick clicked for you, hit that like button and subscribe to Leo Academy for more premium DSA guides. See you in the next one.